Hey guys, Mr. Milton here. Today we're going to start our fourth unit. I'll call it our proofs unit. We'll start with the lesson over congruent figures. At the end of this video, you should be able to name congruent polygons. You should be able to use congruent statements to identify congruent parts. And you should be able to determine whether two figures are congruent based on certain information. Alright, so big idea is that congruent polygons have congruent corresponding parts. Corresponding. Okay, remember that means that it's in the same spot. So, congruent corresponding parts. And so, when naming congruent polygons, always list corresponding or matching angles or sides. I'll say angles/sides in the same order. Okay, and the easiest way to do this, especially if you're given the markings, which we'll try to have all the time, is just to make sure that your markings match up. So here, if we're looking at this figure, remember the angle arcs and the dashes in the sides indicate that angles and sides are congruent. So here we can say that the congruent figures, we can say triangle RST is congruent to triangle. And then what I'm going to do is just make sure that I match my line. So R has one arc, F has one arc, so I know that those match. S has two, E has two, so I know that those match. Did I do that right? F, E, D. Okay, and then D has that arc and a dash, and T has an arc and a dash in it. Okay, now this is called a congruence statement. So when I ask you to write a congruent statement, that's what I'm asking you to do. Tell me what is congruent. Alright, we can go from visuals and to a congruent statement, but we can also go from a congruent statement to visuals and kind of listing the parts that way. We kind of had to do that here. But here's another example. We have triangle TDJ, or TJD, sorry. Triangle TJD is congruent to triangle RCF. We're going to list all the corresponding parts. Remember that our rules for congruent statements is that we have to list the congruent angles and sides in the same order. So I know that T and R are congruent just by how they're listed. I'm going to give them an arc. I know that J and C are congruent, so I'm going to give those two arcs. J congruent with C. And I know that D and F are congruent, so I'm going to give those, I like that little arc with the dash in it. Okay. Alright, any arcs, any measurements or marks that you can make this so that they're congruent to each other. So then what I just said was, okay, angle T is congruent to angle R. Second, I can say angle J is congruent to angle C. And then I can also say that angle D is congruent to angle F. Okay, and that's all from the markings. Remember, we got that from the name. Okay, also, I can say, okay, TJ is congruent to RC. So TJ is congruent to RC. I can say that JD is congruent to CF. JD congruent to CF. And then lastly, I can say that DT is congruent to FR. DT congruent to FR. Okay, we have all the markings that just make sure that we know that. Now here we have the congruent statement and the diagram. We really don't need the diagram. If I have a congruent statement, that's enough information right there to tell me what's congruent. Angle B should be congruent to angle G. K with W and angle Z should be congruent to angle A. Okay, again, we have sides that are going to be congruent as well. BK should be congruent to GW. KZ should be congruent to WA. And ZB should be congruent to AG. And that's all just from this congruent statement. Again, our corresponding parts have to be in the correct order for our congruent statement to be true. So notice how in the previous two examples that each triangle has 6 congruent parts. We have 6 sides and angles together. 3 angles, 3 sides. And so if we want to say that triangles are congruent, we need to have a way to say that, hey, those 6 parts are congruent to each other. Okay? Flipping to the back, it works with more than just triangles. We can use it with quadrilaterals and pentagons and hexagons. 1, 2, 3, 4. In this case, this is a pentagon, right? 1, 2, 3, 4, 5. Yep, there's 5 sides. Okay, and so they give us a congruent statement up here. They say if ACESP is congruent to RWBT DT, find the measure of each of the indicated angles. So we have angle W. Now you'll notice here there's nothing here for W, but in our congruent statement they tell us that W is congruent with C. So if I know what C is 132, I know C should be the same as W. W is 132. Angle D. Angle D, again they don't tell us, but D should be the same as S. S is 88. Then angle B. Okay, they don't tell us, so I'm going to look and see what's B congruent to. B is congruent to E. E's not there, so I don't know that. But I do know that this is 132 for W, and this is 88 for D. Okay, like I said before, it's a 5-sided figure, so I can say, okay, I should do 180 times n minus 2, or 5 minus 2. That gives me 180 times 3, which gives me 540. Okay, so I know that all these angles together should equal 540, so I'm going to just take all the angles and add them together. I got 132 plus 90 plus 90 plus 88, and then I'll just call angle B B. Okay, so if I do that up on the calculator, I should have 132 plus 90 plus 90 plus 88. Okay, that's 400. 540 minus 400 gives me 140. So B should equal 140. It's 140 degrees. Okay, and that's all from our polygon angle sum theorem. That's a little bit of a review, but also from using the corresponding congruent parts. Okay. Alright, so here's some examples. Next we'll say, are the triangles congruent? If so, give the congruent statement. So to prove these are congruent, we have to show that 6 parts are congruent. Okay, again, we said they have 3 angles, 3 sides, 6 parts altogether. And so we're going to just have a proof to write that out. And so what we want to do is make sure we say that what 6 parts are congruent if they are. So we have angle A is congruent to angle E. I can tell that because it's given. Okay. I have, let's see, angle D is congruent to angle B. Actually, I'll say D and B are right angles. Okay, and that's given. And then about those, I can say that D is congruent to B because all right angles are congruent. Alright. Last one I'm going to do with angles. We can see that angle ECD should be congruent to angle ACB. And we can tell that because of the vertical angles theorem. Remember, the vertical angles theorem says that all vertical angles are congruent. Okay, so what we've said here, one side congruent, one angle, 2 angle, 3 angles. We've said that all 3 angles are congruent. From there, we'll go to the sides. And we have that EC is congruent to, okay, so how I do this, you want to go from, I went from E, which has 1 arc, to C, which has 2 arcs. So I'm going to do on the other one, A, C, because A has 1 arc, C has 2 arcs. They're congruent because it's given. Okay, we can say that BC is congruent to DC. Again, I went from right angle to 2 arcs, so here I should go from right angle to 2 arcs, DC. Okay, that's given. They told us they're both 4. And then 7, I went from AB, 1 arc to 90-degree angle, is congruent to ED. And again, that's given. They told us that they're both 3. And so now we proved the 3, or showed the 3 angles are congruent. We showed the 3 sides are congruent. So now our congruence statement, I'm going to say triangle ABC. I can go in whatever order I want to in the first one, but I'll make sure I follow that exact order in the second one. It's congruent to triangle A had 1 arc, E has 1 arc. B was a 90-degree angle, D is a 90-degree angle. C has 2 arcs, C has 2 arcs. Okay, so notice that these aren't random. The first one I can choose however I want to. It should be in order that I can draw without picking up my pencil. But outside of that, I can do whatever order I want to, start with whatever letter. The second one has to make sure that each angle corresponds with this congruent angle. So A matches E, B matches D, C matches C. Oh man, sorry guys. Give you a second to look at that. Okay, so I have to go over that really quick. Given, all right angles. The one that we had to really do on our own was that ECD and ACB are congruent because they're vertical angles. So you see those vertical angles. Everything else was given to us. Sorry for blocking that, but hopefully you see that now. Okay. All right. Well, last, or maybe a first theorem. Okay, our first theorem for this chapter is the third angle theorem. And what it says is if 2 angles of one triangle are congruent to 2 angles of another triangle, then all 3 angles are congruent. Or we can say the third angle is congruent as well. Okay, and that's basically, I mean, it makes sense. All triangles add up to 180, so if I have 2 angles that are the same, that means the third angle has to make it add up to 180, so it's going to be the same for both of them. Okay, so pretty common sense there. Now let's look at this example. It says, can you conclude that the triangles are congruent? Explain. Well, they told me that angle J was congruent to angle M. So J, M, I want to give those both 1 arc. They tell me that angle K is congruent to angle N. K, N, here. And they want us to know if we can conclude that they're congruent. Well, you're looking at these and you see these vertical angles. So that's probably going to be your next one. I want to give it an arc and a dash in here, arc and a dash in here. And we should see that we have 3 corresponding congruent angles, J with M, K with N, and L with L. But are these congruent? The answer is no. And here's why. Notice the markings on these sides. They told us that LN was congruent to LM. Okay, they didn't tell us that LN was congruent to the side of the other triangle. These 2 are congruent to each other, and they have a corresponding side, or congruent corresponding side in the other triangle. So no, sides are not congruent. And outside of that, they did not tell us anything about N and M and JK. Okay, so we don't know if these are even close to being the same at all. All right. So last one, we are going to prove that a triangle or 2 triangles are congruent to each other from scratch. So here we go. They want us to prove that triangle PQR is congruent to triangle PSR. And so I'll start. Remember that we can have givens from a bunch of different ways. It can either be in our diagram or it can be given statements. In this case, all of our givens are in the diagram. So I know that angle Q is congruent to angle S. And I know that because it's given. They already told us it's marked that way. Number 2, I can tell that angle QPR is congruent to angle SPR. Again, that's given. Okay, remember when I'm naming these, I go Q, P, R, I'm talking about this angle. S, P, R, I'm talking about this angle. They're congruent to each other. Okay, I try to make it a habit to go from corresponding angles or parts that if I can. That way, if I need to do a congruent statement, then I'm able to just kind of refer back to it. Okay, so I have those two. And now from those two angles, I know if these two angles are congruent to each other, that means that this third angle has to be congruent to each other. So I can say, okay, angle QRP is congruent to angle SRP. And that is the third angle theorem. All right. Number 4. Let's see, what can we say? We can say that QR is congruent to SR. That was given. We can say that QP is congruent to SP. Again, that was given, marked for us at the beginning. And then the last thing we can say, because we need to have 6 parts, we've said 5 of them so far, we need to say that PR is congruent to PR. Now, why is PR congruent to PR? It's the reflexive property. I told you guys in Unit 2 that we would use this a bunch. And you see that PR is a part of both triangles. It's kind of the shared part. And so it's in both triangles. All right, so here we've talked about how to prove that triangles or figures are congruent. We have to make sure that all the sides, all the corresponding sides and angles have a congruent part in the other figure. All right, we also talked about the third angle theorem and kind of reason why that makes sense. And that's it. Okay, this will be the start of our proofs, and hopefully we can find a way to shorten these down in the future. See ya.